Hello, I'm hoping we're live. This is the second in our series of Southwest Science Chats. So this is a lovely informal chance to chat to some great scientists around the Southwest. So today we're really lucky to be joined by Reg Godwin, who has spent 17 years working in the environmental and water testing sector. He's really passionate about getting people to understand more about water quality, and we're really excited to be doing a project with him, which is one of the reasons we're having this chat today. All the way through, please do send in your questions, because water quality is really important. And in the Southwest, we're surrounded by water. We've got fantastic seas and rivers and streams, and it's really important that we understand what is in our water and how can we all work together to make things a bit better, because I'm sure a lot of us know that there are some problems with water quality in our region. So yeah, Reg, thank you so much for joining us this evening. And
Thank you for having me.
I'd love to just start by just finding out how you got where you are, and what's inspired you to work in this field.
How did I get here? Yeah, it could be a long story, couldn't it? We could take up the whole time just talking about that probably. But yeah, I guess again, I grew up in Devon. I grew up outside of the town of Holsworthy, where we've started this Kingfisher Citizen Science project. And my first job after university was with the Environment Agency. So I studied biology actually at the University of Plymouth, and then I worked at the Environment Agency. So I actually went via sort of 3 months in customer services before I got into the lab, and I was then extracting pesticides and herbicides in samples that have been collected from all over the country. This is what the Environment Agency does in the organics department. So we were using mass spectrometers, and they still do this now, to analyze suites of chemicals, pesticides, herbicides, fungicides, all kinds, in order to monitor levels in the environment. I guess one reason for doing that is to record that and have a record of that. There's also an enforcement side to that as well. So where we have like trade effluents and consent limits, where industry is allowed to discharge a certain amount of a chemical into a watercourse, and monitoring, for scientific purposes as well. So I worked at the Environment Agency. It was my first real science job, and then I moved to a senior scientist role after that. So there was a slight sort of pause in life partway through here, where I sort of had a huge road accident basically, and it reset life a little bit at that point. So I kind of felt, well, I need to sort of prove myself. Obviously had a head injury from this, so I thought I need to I guess work with people who didn't know me before that had happened. Not that the people around me were, I don't think sort of noticed anything different, but yeah, I think for my own kind of sanity, I thought I need to know that I can still do this, and I can still push myself and kind of achieve things. So again, worked in a contract testing lab, where we tested anything and everything, basically, from torpedo fuel to I don't even remember the horse meat scandal. So there was horse meat being used in food products. Phenylbutazone in that, which is a non-steroidal anti-inflammatory, was present. And obviously, this shouldn't be consumed by humans. So yeah, in that quantity. So all kinds done there, and again, lots of pesticide testing, drugs of abuse, workplace screening as well. And I worked briefly in anti-doping, forensic anti-doping, and then I moved back to Devon. We had a 2-year-old daughter. Then she's 10 now, so time has flown by. So then back to the Environment Agency as an inorganic scientist, and then moved on to the technical specialist role with the Environment Agency. And again, that was important when we had the COVID pandemic. So I went into wastewater epidemiology briefly, then for the COVID pandemic, where we were reporting data into the government SAGE group on the spread of the pandemic, using wastewater as a means of tracking where the virus was spreading. So
That's so cool.
and now, yeah, I work for Thermo Fisher Scientific now. So again, that's an environmental role. So it's nice because I have oversight of essentially the whole sort of water testing and environmental industry in the UK and Ireland. So yeah, and supported by really very clever colleagues that are again very helpful and supportive as well. So that always helps, doesn't it?
Oh, that's amazing. So your role now, so you travel a lot, I assume, across.
Yeah, there's some travel. Yeah, it sort of goes in sort of in waves really. It's not kind of consistent, but yeah, again, I travel to most of the water companies. If we sell an instrument there, then I'm an application specialist, so I deal with the chemistry side of things, the optimization of the methods, so the settings and the parameters on the instruments, like a mass spectrometer or an ion chromatograph. So for water companies, that would be, say, meeting the detection limits that they need to see for compounds that are regulated in, for example, drinking water, or it
Yeah.
could be an environmental directive where we need to see, say, really low levels of hexavalent chrome in groundwater or something like this.
Mm,
So I would help with the development of that and to make sure the method is fit for purpose. So
brilliant.
there's a big training aspect to that, obviously, as well.
Yeah.
So, yeah.
So yeah, we will go into hopefully a lot more detail later about it, like
Yeah.
what is actually in our water. Because I mean, a lot of the chemicals you're mentioning, people might have no idea what they are or
Mhm.
why or how they impact on ecosystems or on our health or anything. So yeah, that'd be really cool. And just very briefly as well. So you mentioned that mass spectrometers are something that you deal with. So again, lots of people might not know what that is, but it's going to be, but it's really fundamental to
Mhm.
understanding what things are made of.
Mhm.
So yeah, if you could very briefly explain, if you were working in a lab and you had a mass spectrometer, what you're going to do if someone sends you a water sample, and what can it tell you?
I guess I would think of it as we've got for water testing, we have what everybody knows as those test kits that you use, or paper test kits or little color changing solutions that we can use by the side of a river. That's great for ad hoc analysis, but if you want to get really specific and look at very low levels of chemicals, then mass spec is usually the way to go. So you're essentially you're introducing your sample into an instrument where it is vaporized, and you're filtering out specific compounds by mass. I won't go into all the details because it'd be very boring, but um, you're filtering based on the charge, the mass to charge ratio. So there's a charge, everything has to have a charge and it has to be ionized. So you could tell the instrument, okay, I want to look for this mass because I know my pollutant has a mass of, say, I don't know, 102, and that's what I'll see in the mass spectrometer. So it filters out everything else. Now, that's a very simplistic way of putting it, but imagine you could look for 30, 40, 50, 60 different pesticides at once, to a very low level, to nanogram or femtogram per liter levels. So it's a drop literally a drop in a swimming pool,
Mm,
sort of levels of sensitivity. There's some prep and things that are needed sometimes for samples, especially if we're talking about wastewater samples. Then you'll have particulates and things that obviously the mass spec won't like too much. So sometimes we have sample prep, but actually increasingly instrumentation is getting better and we can do direct injection of samples, providing they're not too horrendous. So
that's awesome. So
yeah.
these instruments can tell you exactly what's in there, so all the chemicals that are in there, and how much of each, which is
Yeah, they can. So there's two parts to that. So one way of using them is obviously to say I want to look for all of these things, and these are the masses for them. So like I said, you could have 60 pesticides. Another way is to run them in full scan mode. So you could scan a mass range and say I want to see anything between a mass of 200 and 700, like the molecular mass. So in that way you can start to see, if you don't know what you're looking for, and this might be what we call like a pollution screen, you could say, okay, I'm seeing peaks, I'm seeing a response for these masses, and therefore it's likely that these compounds, these pollutants,
mm,
that are in the water.
brilliant. So I hope you approve. I've got my chemistry mug today
That's good.
in honor
Yeah,
of you.
I've just got a glass of water, so that's very boring.
This is my periodic table mug. I'm very proud of this.
It's a big mug, isn't it?
It
Yeah.
holds a large volume of tea. Yeah. so, so yeah, we've got a question, and it's something I was kind of going to come to later, but I think we could touch on it now if
Yeah, why not? Yeah.
that's all right with you. So I'm just going to
Mhm.
hopefully make it appear. There we go. So Jan on YouTube's asked, I've heard that drugs, legal and otherwise, microplastics and other nasties are found in small quantities in our drinking water. How did they get in there? So yeah, thanks, Jan. That's really fundamental to why we're doing this and what we want to find out. But have you got any comments on that now, Reg?
Yeah, I mean, I'd say that think about where the water comes from. Drinking water isn't sort of magicked out of the air. It all comes from a natural source at the end of the day. It's coming from a reservoir. The water companies have strict limits and are regulated on what's allowed in drinking water. So I wouldn't sort of panic too much on that front. There are EU regulations that we've transposed into UK law that mean that there are strict limits on those kinds of chemicals and plastics in drinking water. And obviously, I go to these labs all the time. I go to water companies, and there in some cases you have like emerging substances where they might just have to report that there's an incidence of, I don't know, a compound that isn't regulated, haloacetic acids, for example. We just need to have the lowest level possible in there, and then there'll be an investigation to find out and mitigate that and treat the water. So um, yeah, so I mean, it's possible that things can be in there, but most of these, I think you can safely assume, are taken out in that treatment process. And water companies are actually quite good at looking at other things that are in there as well. And I think that's an increasing trend when it comes to what water companies have to do and actually what they want to do, because there's a sort of trend towards looking at what else is in the water so that we can treat it more efficiently. Again, if you're just kind of saying, right, we always treat the water with this much, or we've got this much organic carbon in there, therefore we're going to treat it with these chemicals and put it through this process, that's not very efficient. So if a water company knows exactly what's in there, and we're doing more sort of full scan analysis of our waters that are going to be treated or are going through that treatment process, then the process can be made more efficient and cost effective, actually.
Yeah.
So yeah, but look, all scientists in water labs want to do a good job, and they're scientists at the end of the day. They don't naturally ignore things that are in the water. I know we hear bad press about water companies sometimes in the media. It's simplified a lot of the time. The people working in the labs in water companies do a good job. These are scientists that are very experienced. So I would tend not to worry too much about this thing. Certainly, drugs for abuse and the things like that. I've not, and not at a level that I think that we should worry about, or even there necessarily. So.
Brilliant. Oh, thank you. Thanks for that question, Jan. And hopefully we'll talk a bit more about some of your work, Reg, in what we can learn from wastewater as well. So that's sort of certainly you see higher concentrations of these things in wastewater.
Definitely do. Yeah.
So we can talk about that in a bit. Brilliant. I'll hide that question again. So yeah, so I was saying earlier, one of the reasons that we are having this chat is because we've recently started working with you to try and develop a citizen science project that you've launched. So yeah, it's called the Kingfishers. We're really excited to be working on it with you, and it'd be lovely just to hear sort of where that idea came from, and because yeah, some of you might have heard of the West Country Rivers Trust is doing a citizen science project, which is great, and anyone can get involved in that. You can order kits for that, and it's a really cool project. But yeah, this one is more specifically working with young people. So yeah, Reg, I'll let you explain it.
Yeah, so yeah, it is a citizen science project. So again, you don't need to have any prior scientific knowledge necessary to contribute to it. This is more about recognizing change in the environment. It's a community-based project. So we've started it at Holsworthy Church of England Primary School, and they've been really great. They've been really open to using this project as a way to kind of enrich the curriculum and give children there the opportunity to get involved in a real science project. This is not an exercise; it's something that contributes to, a genuine data global set. A global data set on nutrients and the state of their local rivers. So it kind of came about when I became a parent governor last October, and I guess the idea had been forming about what can we do about the state of our rivers. There's a need in education there as well for the next generation to actually understand monitoring, understand the state of the rivers and our environment, and recognize change and when there is a problem in their local rivers. And actually, not all of these problems are visible, are they? Some of them, some chemicals don't have any visible effect on the environment. So I think I felt quite passionately about getting the next generation of scientists through and having an environmental relevance, particularly with monitoring in the curriculum, and giving children the chance to be involved in something real. Because I don't want to be sitting there in 30, 40 years time telling small children that I knew all these problems and I didn't do anything about it. How do you answer that question when someone says our lifeblood, the water that we drink, that ultimately is in rivers and reservoirs, had an issue, became more and more toxic, wildlife disappeared? I can't live with that notion. So life is short, so we should do something now if we know there's an issue. And I suppose educating children, linking this to the industry, and like I said, with that oversight that I have and the influence that I could have with a project like this was really appealing, I think. So it's an important project. I think we're taking this project to a level that probably hasn't really been done before, with high res, accurate mass, and the use of really high end technology, as well as the little riverside testing kits, looking at, say, phosphate and nitrate. Those are the main pollutants that we get from, say, agricultural runoff and fertilizers that really damage the rivers, as well as wastewater. So I think I mentioned it earlier, Alice, you don't necessarily really get introduced to environmental science unless you choose to at sort of a higher education level. You could go through primary school, secondary school, A levels, even university. If you hadn't chosen a scientific sort of discipline, you might not have any idea about this kind of thing, apart from the odd report in the media that there's been a spill here or discharges here in this river and something's happened. So to me, that idea and that sort of knowledge needs to be introduced really early on at primary age, when you're going to get some kids remembering this and taking this forward and owning the sort of natural assets around them, caring for them and looking after them. So it's super, super important, and it applies to all of us, doesn't it?
Absolutely. Yeah. I think I think schools are doing an increasingly good job of considering global issues in their curriculum and in their work. But I think for a lot of people, the main focus is on climate change, which is obviously extremely important and pressing. But actually, a lot of these global issues are interconnected. Climate change is going to impact on the water, and it's really important to look at all these things really holistically, isn't it? And understand how connected everything is.
Definitely. So I guess a point I'd add to that is, again, the media reports climate change in terms of temperature increase. Usually, it used to be rising sea levels, didn't it? But we seem to hear more about just the 1.5 degrees. But a problem that we barely ever hear about is the nutrient issue. So levels of nitrogen and phosphorus in our waters, and what that does to our fresh waters. Because we use huge amounts of these in agriculture, and we mine phosphorus and put these in fertilizers. We spread globally, it's something like 20 Great Pyramids worth of phosphorus and 120 Great Pyramids worth of in terms of weight of nitrogen every single year we put on the land. So there's some really interesting papers on that, and how the southern hemisphere and the northern hemisphere tend to and different stages of countries at different stages of sort of development and wealth would tend to use one or the other. But it's an issue that really affects biodiversity through eutrophication and affects invertebrates, and then the knock on for all the other species that feed on those invertebrates and so on. So
yeah, that's really scary. So there is this definite need to engage everybody with this issue, but I think starting with the kingfishers, starting in schools, you're not just engaging the children, then you're hoping that they're then going back and talking to their parents and caregivers, and that you're engaging then communities in this, which is just so important, that people feel some ownership and some
100%. Yeah, definitely.
in terms of the environment, because often, like you say, water companies get a lot of stick, and sometimes rightfully so. I think they do.
Yeah. I mean, look, water
We get
companies, people talk about shareholders and people at board level. Scientists I work with day to day in the labs, ensuring that we have clean drinking water, do a very good job. So I wouldn't say anything against them. The company as a whole, that's a political conversation, isn't it? But
I think also, sometimes with a lot of things, we forget that we have a role to play, and it's easier to sort of say, oh well, yeah, but they're not doing their job properly, and actually that doesn't mean that you can't also contribute to making that job easier, because sometimes we forget that there's whatever we're flushing down the loo or putting down the sink, or what we consume, it all massively contributes to that water quality issue, and we need to we can all make easy changes, which we'll talk about a bit more later, but
yeah, of course we can. So I guess I'd say on that in terms of communities doing this, that the whole point is that communities have much more power than they actually appreciate a lot of the time, and that collective group voice it is really significant and can really spark change, and the industry will sit up and listen, and so will MPs, and therefore we can cause change in the industry. But also the size of communities, if we think about the number of town villages across the UK, this depends how you define a town and a village, but if we say 45,000 towns and villages roughly, imagine if we have 2, 3, 4, 5 people in each involved in something like this, even if it's just monitoring and noting change rather than doing the chemistry. That's a massive number of data points. Even if they take one sample or do one sort of ecological study a month, that's a higher resolution than any organization could provide in the world. The Environment Agency does an unbelievable job in their labs. They need more funding to do that, and to enable them to meet the needs that we face and the pressures that we face from the climate today. So I would say that's a major thing, that funding for the EA has been cut, I think effectively 50% in the last decade. And the EA actually recognises that citizen science is part of their 25-year plan and the strategy. It's an important thing that can complement the data that they gather themselves. So my point there is that the resolution and the local knowledge of local water courses and the observation of change cannot be matched by any other organisation. So communities are absolutely key to making that change, and sort of taking responsibility and owning their own sort of environments and natural assets.
Yeah, this is where citizen science is just so important. You don't have to be a scientist, you don't have to be a genius, you don't have to, it's really harnessing the power that people have, and they're, humans are amazing at pattern recognition. We're amazing at spotting when something's changed. We're, and those, we can harness all that. We can, and like you say, create these data points all over the place, that if it was just, if we're relying just on the sensors that the water companies have, or that the Environment Agency uses, we can help so much by just more of us getting involved.
Exactly. Yeah, no, you can really just supercharge it,
Yeah.
and data is knowledge, isn't it? Essentially, that allows us to make better decisions. So,
Yeah.
I think more data is much needed. We don't even know some of the things, obviously, in our water that are harmful to us.
Mm.
We know of some that are not regulated, but and are potentially more toxic than the ones that are. But there's a whole. But yeah, this goes on and on, doesn't it? More chemicals will be introduced. More chemicals will exist that are toxic. Herbicides, pesticides, you name it. So more data is better.
Yeah.
Definitely, I'm a fan of data.
Absolutely. There's a really cool project actually the North Devon Biosphere are doing at the moment called Smart Biosphere, and they're working with South West Water, and they're setting up a load of smart sensors right along
Yeah.
the water along the river to try and really regularly monitor any changes, and yeah, it's a really cool project if anyone wants to look it up.
I think that use of technology for automated and sort of remote monitoring, it's really come on in the
Yeah.
last 10 years. So
Yeah.
again, really useful. We can use technology and then AI obviously as well to
Yeah.
interpret that data. So
Yeah.
yeah.
Super cool. So let's chat about what's in the water.
What's in the
I
water?
think, things like what the Kingfishers have done. So at the moment, the Kingfishers project, they've been linked up with Earthwatch, haven't they? So they've been predominantly measuring turbidity, which is how
Yeah. Yeah.
clear the water is.
Yeah,
Um,
so they measure a few things. There's like a sort of written ecological assessment that they do every month. So they're looking at the sort of the wildlife there, the plants that are on the riverbank. They look for visible signs of pollution. So foam, oil, color change in the water. They do look at turbidity as well. So they have a measuring cylinder to do that, and then they have some chemical tests for nitrogen and nitrate and phosphate as well. So they do that, on the riverbank and compare that to a color chart as well, and that gets all recorded and it gets sent off via the freshwater watch app. There's a specific app for that, and that goes onto a global database where you can look at again sample points and data from all over the country, all over the world. There are thousands and thousands of data points on there. Last time I looked, I think there were something like 50,000 or something unbelievable like that. So that's what they're contributing to.
yeah, but what you're wanting to expand this to is to do a much more extensive analysis of what's in the water. So in terms of like why are people measuring nutrient pollution? What is the problem with that? What's it going to cause in terms of ecosystem damage? And
So essentially, I mean, nutrients. So we're talking mainly in terms of issues. That there are others other than this, but if we talk about nitrate and phosphate, N and P, we refer to them as that are in fertilizers and present in slurry and things like this that we spread on the fields to enable crops to grow better. When that runs off and goes into a river, it kind of plays havoc with the things that already exist in that river. So that could be bacteria, it could usually be algae and plants, maybe more opportunistic plants, invasive species that will grow much more quickly than the native species that are there. You then obviously get sort of a blanketing effect and eutrophication in some cases. Ultimately, biodiversity and the sort of range of different species in that water body decreases dramatically because you have one species that outcompetes everything else. So again, that can cause temperature changes. If we have blanketing, you have less light reaching the sort of bottom of the watercourse, and importantly, oxygen levels as well can change. So this can affect invertebrates and fish as well. So that's the point of monitoring nutrients. Like I said before, they are a global issue. It's linked back to sort of land management, I guess, and how fertilizers are used, but also the extreme weather now. So it feels like in Devon now we have sort of a monsoon season and then a drought in the summer. So that's had a huge impact with the amount of runoff that we see and flooding and nutrients reaching places that otherwise, they wouldn't, in concentrations that wouldn't normally be seen. That causes a major upset for organisms in the river, plants, bacteria, and other wildlife. So yeah, important to monitor those. Again, if you're consuming these as well, and these are regulated in drinking water, then you can have problems as well. So they seem kind of simple molecules, but nitrate, for example, can be carcinogenic. So there's issues around those. But again, those are regulated in drinking water. The effect in river water is it causes sort of unusual growth in species that wouldn't normally exist in those water bodies to that extent.
So what would you? We want to measure other things in river water. So there's some really great organisations doing great things. So Pharma Hub is looking at things like pharmaceuticals in water. We've recently also done worked with the Citizen Phage Library on looking at viruses that are in water, which sounds very scary, but these are good viruses that can kill potentially bacteria that are resistant to any antibiotics. So these are sort of big threat to us. So through overuse of antibiotics, both in farming and in medicinally, we are seeing this huge rise in bacteria that don't respond to antibiotics anymore. I mean, water is fascinating for just it's in terms of, I think for this project, the Kingfishers project, it's really fascinating to look at these links between our health and the water, both how the water impacts on our health, especially if it is not healthy water, but also being in nature impacts on our health. There's a huge number of studies about that, aren't there? But also, what are we putting in the water? How are we impacting on it? And so this project, hopefully, through looking for these more unusual chemicals, will start to build an idea of what's actually in there.
Definitely, yeah. So I mean, I think that's where Kingfishers is probably different to maybe other citizen science projects that we will look at complex organic molecules. The other main pollution source, of course, is especially in rural areas where you've got agricultural runoff and things, is wastewater. So where we have treatment works that are constantly discharging and can't cope with the hydraulic capacity with this extreme weather that we have. In some cases, maybe it's extreme weather. In some cases, not. And you can, all this data is freely available. You can see on the Rivers Trust sewage map that some works are discharging for a quarter of the year. It's a huge problem. So nitrate, phosphate from runoff, that seems fairly sort of straightforward to get your head around. But when you start talking about wastewater, then it's anything in there that you're potentially flushing down the toilet or putting down the drains. So yes, metabolized pharmaceuticals, your body essentially wants the chemicals that you consume to be more readily taken up by water. So it tries to make these compounds more water soluble. So you get the metabolites of those. And again, surfactants, something that's sort of on the radar for the scientific community and has been for a few years now is PFAS. They're found in flame retardants, and they're very persistent organic molecules. So essentially, they're hydrocarbon based. They have a backbone of carbon and hydrogen, but they contain fluorine atoms. If you think of fluorine as being sort of almost like a little shield in terms of an atom around the molecule, it protects the molecule. It means it's essentially persistent in the environment, because without that, you get UV degradation and organic molecules break down, and then they're not so much of an issue potentially. But with fluorinated molecules, same as you think of like fluorine in toothpaste. The fluoride protects your teeth, doesn't it? It does the same for organic molecules. It makes them very difficult to break down, so they accumulate. And in terms of human toxicity with PFAS, there's sort of significant worrying effects they can have on things like fertility and things like that. So yeah, really important to understand what's in the water. We worry about what affects humans. Imagine what that does for more basic organisms, invertebrates, fish, and things like this that are essential to that food chain and that habitat and that ecosystem. So yeah, understanding is key, isn't it? And finding out actually what is in there at what time and at what concentration. So I think that's really important, and that's I hope where kingfishers will be different and kind of excel.
Yeah. Another thing a lot of people are talking about at the moment, I'm glad it's finally being talked about, is road runoff. So, most of the water on the road, it literally just goes straight into the waterways. It's not being processed first, and it's coming, straight up into the sea. And if you think about that is full of toxins, and it is, we don't think about this, but tire dust, as tires wear down, in fact, as electric cars become more prevalent, obviously that's a brilliant thing, but it does also mean they are heavier cars, their tires are going to wear faster. And so we need to think about what we are doing with that road runoff, because it's full of microplastics and a load of other quite crazy chemicals. So yeah, that's.
And again, it's been sort of unregulated. It's been something that's sort of seemingly kind of overlooked, because I suppose these weren't really official sort of discharge points. They were just drains, but now we have this extreme weather, and they turn into sort of discharge points in themselves, don't they? With like you said, microplastics and all kinds of I imagine there are metals and all sorts from catalytic converters and things, and plastics and things from the tires and petrol based sort of chemicals. So yeah, really interesting. Again, it's been on the radar more recently, I think, with press coverage. So so the media does do some good things.
It's good. It's good that these issues are being raised. So yeah, what in terms of how bad is the problem? How bad would you say our water is? Because we see news articles saying that our water quality is really, really poor. Is that compared to the world? How bad are we? Bad
it's
compared to other places? And
it's a tricky question to answer, isn't it? Because I guess when we assess the waters, and this is what the Water Framework Directive does from Europe, it sort of assesses how far away from natural conditions that the watercourse is now. At the moment, there aren't any water bodies in the UK that are chemically classed as good. They will fail. And ecologically, I think at best some are moderate. So as ecologically, we're talking more about again invertebrates and other species, and whether there are invasive species present in the watercourse. So this is kind of hard to look at. There are sort of nuances around that, in that one of the reasons why everything is classed as failing chemically is because we added in extra pollutants in 2019 and decided to look for things that had become apparent, I guess, as that project went on. So everything was reset to failing status. But again, we're monitoring them because they're quite often there. So again, it's PFOS, PFAS, pHs, pesticides and herbicides. So it isn't good, but it's about understanding change is the point of all of these programs. Are things getting worse? Are there new things that are worth monitoring? And what are we going to do about them? So again, it comes back to collaborative efforts, I think, between NGOs, citizen science projects, and the Environment Agency, and I suppose the government waking up to the fact that these operations need funding. And the Environment Agency can monitor these things, but they also need to put in frameworks to do something about it, and that obviously costs money as well. So they really need to take that, I think, seriously in the next, well, immediately. I was going to say in the next few years, but that's we're already quite far down the road at this point. And I feel like the sort of environmental issues, there was a lot of talk around the Paris Agreement and COP21 and 1.5 degrees, and not exceeding that limit, and it went quiet after that. The government sort of thought about other things, and of course we had things happen in the world that maybe took up that media space, but yeah, the environment didn't stop changing, pollution didn't stop happening. The next generations are going to have to deal with this, and it's going to be much worse than what we have to cope with now. That's the sobering thought. So let's educate now. Let's understand as best we can what the issues are in our watercourses, and start funding it properly and doing something about it. So yeah, the picture is not great, but you have to stay positive and say, well, if there's an issue, we need to do something about it. Let's not despair about the situation. Let's act and do something about it.
Absolutely, that's what we're all about. So, so yes, I'm just trying to look through my questions. I suppose, yeah, it can feel really bleak. So in terms of acting,
Mhm.
yeah, you could definitely get involved in a citizen science project. So the West Country Rivers Trust one is a good example. If you, as just a member of the public, want to
Mhm.
get involved in some way, we're hoping to work with a lot of schools
Yeah.
through the Kingfishers project. But if you're just a person who is just a citizen that cares, but not necessarily wanting to get involved in the citizen science project, what can you do? How can you help towards tackling this problem? And what also should you be looking to spot? I mean, if you're someone that walks your dog along a canal every day,
Mhm.
we talked about this the other day, that if
Mhm.
you see something weird, like a lot of foam or something, you'd probably just think, "Oh, that's awful." But then you'd also assume, "Oh, someone will have reported that."
Yeah.
Unusual someone. But what if they haven't? What if everybody has walked past and gone, "It's all right, someone would have reported that." So who should you report these things to, and what should you flag up? Like, what is a worrying sign?
I think so. This happens all the time, and it happened to me actually a couple of years ago. I was walking along next to a canal, and the hillside next to the canal had literally a sort of waterfall of sewage coming down, and you could smell it for like miles around. It was blatantly obvious, but hundreds of people were walking by and just carrying on their daily things. So the message is, don't walk by,
Mm,
report it. The first thing I would do is call the Environment Agency incident hotline. So there's a number. Maybe we could put that in the
oh, yeah,
in the in the chat description. It's 0800 80 70 60.
I will.
Phone that. You can phone the water company as well, and they will definitely act and come out and do something about that. But just going back to what you said initially, you said you're just a citizen, but you're not just a citizen. The
Mm,
citizens are, you have eyes, you can do something about this. If you're not happy with something, if there's a gut feeling that something doesn't seem right,
mm,
then stop and do something about it. Record it, report it. You have a voice to change it. If everybody does this, then that's a really powerful movement actually, that can
mm,
change the industry and make everybody more accountable. It's about caring at the end of the day. But I would say, write to your MP, talk to your MP, and say that you want these issues raised in Parliament. Your MPs are there to represent you. These are
mm,
issues that affect your health, that cause cancer, that change people's lives. There's nothing more important than that. So write to your MP, make it an issue, make it their problem, and get them to talk about these issues. In terms of, I suppose, what you might notice, if you're walking past a river, then we talk about foam, don't we? Quite a lot of foam on rivers, and you see it when there's really high rainfall.
mm,
Some of that can be natural. You'll have sort of more stagnant waters, and breakdown of natural organic compounds, um, and organic material actually, that release sort of natural surfactants and cause foam on a river. So that's not necessarily an issue, but if in doubt, then of course report it if there is a lot of foam on a river. It could be a genuine pollution incident. It could be a natural occurrence. Again, color change, oil on the water, as we talk about turbidity, things like that. And something we refer to as fish kill incidents. So if you have obviously fish on the surface of the water, or changes in animal behavior, again, it's just worth reporting. Again, if you catch it early, then the damage might be we might be able to limit and then mitigate more easily. So
Is there
um,
something about an algal bloom that causes the water to go? I can't remember which colour it goes. No, isn't there?
you can get blue-green algae in
Oh,
reservoirs, and
yes,
so that's something you see. But again, you can
a
get blue.
reportable thing. If you saw that, should
Again, I would report it if in doubt.
yeah.
I think you should report it. Where you have stagnant waters and high nutrients, you can see this just in sort of puddles along a farm track, where nutrients have entered the water. You can get blue-green algae in sort of small quantities there. So it's less likely in a river. It should be less likely because you have that flow, hopefully. Um, but again, flow is less consistent than it used to be because of changes in the weather. So it will be a massive problem in summer when we have droughts and we have to think more about storing water, and water does flow at a lower level or become stagnant in rivers. Um, that water flow and that temperature of the water signals to organisms to do something, and to, for example, with Atlantic salmon, to migrate. They might have been there in freshwater for 4 years before they migrate to the sea, and then come back after another year. If the cue that they get to migrate, and often it's water temperature and flow, is wrong because it's an extreme event. It's not the consistent thing that, okay, this is winter now, let's go. Then those populations die out, don't they? And we end up losing. There's been a massive decline in Atlantic salmon. So, yeah, the predictability of the weather, or the lack of, doesn't just cause issues for us. It's obviously affecting our wildlife as well.
Yeah, yeah, it's quite scary.
It's slightly daunting, isn't it? Yeah.
But it is so important to recognise that we, like you say, we have a voice, we have the ability to help work towards change,
Yeah.
and to work with all these agencies that are trying, So,
Yeah. But I
and
think talk about it like every day at work. Talk about it to your children. Talk about it to your niece, your nephew, at work, in your class if you're a teacher. It's part of the everyday conversation. It should be. In many cases, we carry on, don't we? Life is busy, so it is something that we should work into. And actually, in terms of businesses as well, sustainability will become, and is becoming, fundamental to how businesses operate. We see this more and more, that green criteria, whether you're buying an instrument or you're getting contractors to do some work on part of a building. There is now that green question in there when it comes to a tender, or a sort of a technical specification for a certain piece of equipment. So there is change, but yeah, we need it to be faster and better.
And also, we can all make a difference in terms of reducing the amount of water we use, which reduces the pressure on the facilities that are trying to clean the water.
Yeah.
And also what we are flushing down. We are responsible for what we put into the water, and we can definitely make a difference through that, can't we?
Yeah, I think, there are obviously like eco products available in terms of, washing up liquids and washing detergents and things that are lower in say phosphates, for example, or surfactants. I would really like those to have actual environmental, traffic lights, a label. How persistent is it in the environment? How damaging is it to aquatic life? I think that's something that's worth doing. We do it for, other, food products. We have the traffic lights, don't we, for how much fat, how much salt, what percentage of your daily intake is that. Why don't we have it for products that end up in the environment? So there are choices we can make around that.
Those
Yeah,
symbols are so small on the back of chemicals. Sometimes you see this tiny little symbol implying it's corrosive or it's
yeah.
damaging to aquatic life.
Mm,
And that should be huge. There
mm.
should be a massive sign across it saying,
Bigger would be
"Don't
big.
pour this
Would be
down your
good.
drain."
If we talk about relevance, it should be much bigger, shouldn't it? But
Yeah, yeah,
just for public awareness, not everybody knows about these things. Not everybody is an environmental scientist,
no,
and not everybody will realize that if you put that down your drain, whether you're on main sewage or not, that could still end up in the river untreated as you put it down the sink. So
yeah,
um, yeah, I think uh, traffic lights in that respect, and actually the government's subsidising those, not going down the route of it's a sugar tax, you're going to have to pay more for
mm,
something that's bad, but actually pay less for something that's ecologically less damaging. So I
yeah,
think those products, eco products, should be subsidised so that we can all benefit from them.
yeah. I think we also all just have a bit of a I don't know. Sometimes as I go through the supermarket, I look around and think we have rather an obsession with using chemicals that are
We
completely
do.
unnecessary. And it's, there's the classic line of there's all the body washes, and then on the other side there's all the moisturizers because we've completely dried out our skin. We're
You
constantly
two want it. Yeah, you need one
trying
too.
to balance out these things.
It's
And I think,
consumerism. Yeah.
yeah, it is, and it is, yeah. We could just use less.
We
That's
get. Yeah, you're not wrong.
okay. Cool. So we've covered a lot of things, but is there anything that you wanted to chat about that we haven't mentioned yet? Or
It's we could talk for probably another 5 days about it, couldn't we? I think so. There's a lot to cover, but I guess the main thing is in terms of the citizen science element to this is that you know you can do something about it. You can get involved in a project like Kingfishers. You can make a difference to the environment and therefore the health of future generations. That is the takeaway. All you have to do is care and get involved. So um, yeah, it's easy to think that the government has this covered and that somebody else is thinking about it. Everything will be safe, but we know this is not always the case. And also there are people out there doing an amazing job. Um, the EA does an incredible amount of monitoring of our water bodies to try and keep us safe and actually improve things for wildlife as well. So let's collaborate, appreciate, not vilify so much, but work together, try and make things better, find a solution. That's the way forward, isn't it?
yeah, I think that's brilliant and a lovely note to end on. So thank
Yeah,
you so much, Reg. And anyone that's watching this afterwards, if you've got questions, I'm just going to put you on the spot here. Is it all right to ping them your way?
yeah, of course. Yeah, always open to questions.
Do get in touch if you've got questions for Reg. He's a real expert on. I think has a really sort of broad oversight over water quality across the UK and Ireland. So please do get in touch and ask your questions. Do look up the various opportunities to get involved directly in citizen science or in just noticing more what's in the water around you and the ecosystems around the water, and just look for changes. And like Rich says, do report things. Don't assume somebody else has, and it'll all contribute to building this big data set and starting to really understand what the issue is and start to tackle it together. So thank you so much, Reg, and thank you for all the awesome work you do, and for getting involved and for contacting us and letting us work with you on this project, because it's really, really exciting. So hope Kingfishers grows into something awesome and makes a big difference.
I'm sure it will. Yeah, thanks so much for having me. It's been a pleasure.
Oh, thank you.